Welcome back to the second part of this video where I show how to apply modular design in MuJoCo. In this part, we go over to the interesting part, which is accessing the sensors and actuators of individual models and programming the control logic. If you missed the first part, the link is displayed on the screen. Watch it so you can know how we arrived with this model. So first, I'll go ahead and print or generate the compiled model which MuJoCo actually uses. You can get this by clicking on Print Model. Then, in the directory where you launched this, you will find this file. In the directory where you launched MuJoCo, you'll find this file that was generated. Here you have all the details of the current model. Now, one thing that's important is how to know the location of each sensor, actuator, and data. Everything is stated here. How many actuators you have, 7 in total, how many bodies, number of sensors, and everything. What's also important here when doing modular design is naming. Giving names to every body, every sensor, every actuator you're adding. Try as much as possible to give them descriptive names. This is also one of the changes I made in the conveyor model. I added names to all the sensors and all the actuators for easy identification. So when you go over to this compiled model, you would always find a name for each of the sensors and actuators. Names can also be assigned to the bodies, but I didn't do that because it is of no importance. So if I search for sensor 0, this is the beginning of the sensor list. You can see that for the left conveyor, we have the velocity meter. For the left, we have a touch sensor which is at position 1, and then the next, and so on. So you have for all, up, right, etc. Another thing to note about the sensors is that here you also find the dimension. For example, the velocity meter has a dimension of 3, meaning it has 3 values. The touch has only 1 value, and so on. What you can also get from here is the sensor address. Since this is the first sensor, the address is 0. Since it has a dimension of 3, it takes positions 0, 1, and 2. That means the next sensor will begin from address 3, and so on. So the address of the next sensor is determined by the dimension of the previous one. The same applies to actuators. Each actuator has a name. Now, another important thing is the parameters. Each of these parameters is stored in the model. One thing I would use later on is the actuator gear, which specifies the axis of motion for the velocity actuator. Let's go back to the code. I have separated the code, the one which comes from MuJoCo and was taken from the MuJoCo template. It's all in the main.c file. The only thing we have to do is to specify the controller callback function. So all the logic I moved to a separate file, which is logic.c, and I also created a header file for it, logic.h, which is imported in the main.c file. In it, I have everything. I created an enum to represent all the sensor locations in the sensor_data array for easy access. I also created some helper functions to make the coding easier. Then I created the main controller callback function. First, we just need to keep track of where the object is located. So now here, I set different speeds for each conveyor belt at the start. Then I go through all the belts and check if the object is on the conveyor belt. If the touch sensor of the conveyor belt is active, which I check by accessing the value of the sensor from the sensor_data array using its address. It returns true when the absolute value of the sensor is greater than 0. The conveyor with an active touch sensor becomes the active conveyor. Then I set the velocity of the box to the velocity of the active conveyor. Because we set the speed of each belt separately, the speed of the box varies each time it enters a new conveyor belt. Now, for the direction, I also changed the direction of motion. This is where the gear comes in. Since the actuator only moves in one direction, defined by the gear, I must switch the box's motion direction through the gear values. Going back to MuJoCo, if I put a frame on the board, you'll see that for the left conveyor, the box should move in the negative x direction, which is what I specify in the code. For the up conveyor, it moves in the negative y direction, again, specified in code. Same for the other two belts. Right positive x, down positive y. So I use the gear array. Each actuator gear has 6 values. I get the actuator index from the enum, multiply by 6, and set the correct gear axis, x equals 0, y equals 1, z equals 2. That's the main and most tricky part of the whole logic. Aside from that, nothing much. So the code just loops. I set the speed and change the box direction accordingly. Now, for the cylinder, I check the state of the light sensor, and if it's active, only the right one is used. I activate or extend the cylinder. That's it. When we compile and run this with make, everything builds. I made a small change to the make file too. Now we have the binary here. When I execute it, we see this behavior. The left and right conveyor speeds are slower compared to the others. And that's it for this video. You can get all the files from my GitHub repository link in the description. Thanks for watching, and don't forget to subscribe. See you in the next video.